My name is Chris Lehnig, and I'm a PhD student in the Computational Sciences program at San Diego State University. My advisors are Drs. Karen Campbell and Jose Castillo, who are both co-authors on our poster titled Surface Expression Risk Assessment Data Feasibility Study. The question we are trying to answer is, can readily available data be used to investigate surface expression risk dynamics in older oil fields of Central California? I'll start this presentation with some background information and the description of the study area. Then I will go through the data components being used. Next, I will share some visualizations that highlight our findings, and I will conclude with a brief summary and the importance of continued research. Surface expressions are the unexpected flow of fluids to the surface during oil production operations. They can be high energy events resulting in surface explosions that launch rock and debris hundreds of feet into the air. Surface expressions have been recently observed in Central California's older oil fields that produce heavy and thick oil from a rock called diatomite. Their exact cause is unknown, but they are believed to be associated with the use of cyclone steam injection into diatomite reservoirs. Cyclone steam injection is an enhanced oil recovery method where high pressure steam is injected into a reservoir and is left to soak for days or weeks. After the soaking period, the same well that injected the steam is opened and put on production. This process is repeated until production is no longer profitable. Our current goal was to determine whether tiltmeter-based ground deformation data paired with well operations data could provide the information content needed to perform a robust risk assessment study. The long-term goal of our research is to understand and quantify the dynamics and evolution of risk associated with surface expression events. Our study area was a 0.4 square mile region of the Midway-Sunset oil field in Kern County, California. 753 wells were drilled in the study area between 1923 and 2019. Cyclone steam injection was introduced to this area in the 1990s and has been followed by 23 surface expressions between 2010 and 2019. Tiltmeter surface deformation spatial grids were provided per hour from April 2004 through December 2017. Each spatial grid represented net vertical deformation across space over a 1 hour period. As seen in this figure of tiltmeter surface deformation grid coverage varied along the edges of the study area, but was very consistent in the center. Surface expressions marked on the map by white circles were spatially clustered in the eastern region of the study area and had good associated tiltmeter coverage. Over space and time, approximately 3 billion deformation samples were provided and processed. Well data included surface and bottom hole locations, drill dates, well depths, a monthly status per well, and monthly production and injection activities. Here we take a look at surface net deformation in relation to surface expression events. In the figure on the left, we mapped tiltmeter surface net deformation during our coverage period from April 2004 to December 2017. Surface expressions marked by white circles were spatially located near areas that experienced the most extreme uplift, the dark red colors, and the most extreme subsidence, the dark blue colors. The figure on the right shows daily sequences of 24-hour net deformation for the 8 days prior to the surface expression of August 3, 2011. We observed patterns of subsidence and uplift local to the surface expression location, marked by the star on each panel, in the days leading up to this event. Similar maps were made for all surface expressions. Local and regional deformation patterns were observed throughout the study period and were not always in the immediate area of surface expression events. To investigate whether surface expressions were associated with cyclone steam injection activities, we mapped total steam injection volume per well from January 1977 to May 2019. The figure on the left shows well surface locations colored for total steam injection volume, with surface expressions marked by open red circles. The 3D perspective on the right represents the same data but shows well courts, bottom hole locations, and surface expressions marked by red vertical dashed lines. The highest cumulative steam injection volumes were observed in the northwest region of the study area, an area void of surface expression events. In the 3D perspective on the right, you can see that surface expressions were spatially associated with more densely spaced wells drilled to the shallowest depths of the study area. Tiltmeter deformation data was found to be highly informative in the context of surface expression risk dynamics. Surface expressions were observed near regions that experienced the greatest uplift and the greatest subsidence of the tiltmeter surface. They were also observed in areas with the largest density of drilled wells. Surface expressions were not spatially associated with wells that had the largest steam injection volumes over time. Results from our studies support the use of tiltmeter deformation data with well operations data to investigate surface expression risk dynamics. A better understanding of risk may help support sustainable operations, inform oil production policy, and provide a safer environment for employees in the field. If you would like to discuss this topic, please come see me at the ACSESS event on Friday, April 8th. Thank you.